Hi, I'm Scott Knowlton, and I'm the Product Marketing Manager for our DesignWare PCI Express products. And today I'm going to be doing a demo of our PCI Express solution, which includes our DesignWare PCI Express controller and our DesignWare PCI Express PHY. And for today, we're going to be using a 45 nanometer PHY. So let me show you what our demo is going to be. First, I'll start with our Sitka 2 board, which has a Vertex 5 FPGA on it. That'll be holding our DesignWare PCI Express controller. And in addition to that, for our PHY, we have this 45 nanometer PHY on our Synopsys test board for our PCI Express. And we use a 2-board setup so that we can test different PHYs with our controller. So those different PHYs may include things like different geometries, so 130 nanometer, 65 nanometer, and also 45 nanometer. And then also today we're going to just be using this little adapter here to force the hardware to be seen as a single lane or by one PCI Express controller. Okay, so let's assemble our board. So we're going to take our Sitka board that we talked about earlier, and we're going to take this using the Type-C connector, which is an industry standard. We're going to put these two boards together like so that we can create our complete PCI Express solution. Then on the bottom of this, we're going to add our hardware connector, which is going to force it into a single lane operation. Then we're going to go over here to the standard PCI Express, or the standard motherboard that has PCI Express. And this particular motherboard has an available PCI Express 2.0 slot, and we're just going to stick it in there like that. Okay, so now let's power up the system. First, we're going to turn on the power supply, give us power to the motherboard. Then we're going to reach around here and to the on switch on this particular motherboard and click it on. And then what we're going to do is we're going to see the system boot up standard Windows XP operating system as we go through the boot sequence here. The first thing we're going to do is we can have multiple PCI Express cards in the system, so we're going to connect to our specific card. And then we're going to go down to basically this is the console window that allows us to do various functions, which we'll get back to later. And then we also have a performance window that allows us to show the different rates that transactions are happening. Now, in order to get this to automatically update, I'm going to tell this to auto update, and then I'm going to start these counters. The next thing I'm going to do is put on the rate display, which is going to pop up another window, and it's going to give us some information. So it's going to tell us there's a single lane. It's going to tell us that the link speed that it came up in is 5 gigabits a second with a theoretical max of 5 gig. And also the card is showing that it's up at 5 gig through the top here on this particular window, that it's 5 gigs support with a single lane. So we're supporting PCI Express 2.0. So just to prove that this isn't demo wizardry and we've mucked with the numbers and software, let's use a shareware utility called PCI Tree. We're going to go in here. Now the first thing we're going to do is find our particular PCI Express device, and in this case we see the Synopsys device is 16C3. So we're going to select that one. Then we're going to select a 64-bit address configuration register space, and then we're going to dump all the registers in that space. So now if we go down and we look at 7C, we can look at the capabilities registers. And so in the first couple of bits here, this 2, which is binary 1-0, tells us that it's in a Gen 2 mode, or supports 5 gig, and then this 1 here implies that it's advertising itself as a single lane device. So now if we scroll down to location 82, offset 82, we have to start at register 08, but then we have to go, because we're at 82, we can see that we're linked up as a Gen 2 or 5 gig device with the binary 1-0 and also as a single lane. So now let's go back to our software and do some performance runs. So now if we look at the link rate, we can see that the numbers are actually very low for both the transmit and receive. And so what we're going to do is go back over here to our control window, and we're going to take and we're going to write some data to system memory. So this has memory or data coming from the card into system memory, and we're going to do a continuous write in order to generate traffic. And so in order to do that, I put it on continuous, and now I'm going to go issue. And so if we go back over here to the rate display, you can see now that the traffic is coming from the card, so it's doing a transmit, and we get to almost 3.9 gig throughput. So this is, as we said, the theoretical max is 5 gig, but with 8B, 10B encoding, the maximum that you can get due to the 20% loss of the encoding is 4 gig. So you can see on a single lane device here, we're getting almost our theoretical max at 3.9. So now let's go back, and we're going to stop the writes, and we're going to do the same for a read. So now our card is going to be reading from system memory. We're going to do continuous issues of reads, and so let's issue those. And what we'll see when we go back to the rate window is that we are now at 3.3. So the receive channel is below our theoretical max of 4 gig. Our read throughput is influenced more by the chipset on the motherboard and the protocol overhead than our transmit was. We also see the transmit numbers in this read are up from their steady state as well. This is due to the circuit board making read requests through the chipset to the system memory and the protocol overhead in doing the reads. This concludes the demo of our PCI Express 2.0 solution, including the DesignWare PHY and the DesignWare PCI Express controller. Thank you for watching.